Good morning, everyone. Welcome to INE's webinar for configuring DOT1X and MAB. For some of you guys who do not know me, my name is Rohit Pardasani, and I would be with you, teaching you DOT1X and MAB. As far as certifications are concerned, something about me, just a quick preview. I've been in the industry for about 17 or 18 years now. Have done my certifications like CCNA, CCNP, but as far as the CCI is concerned, I have 5 of them, which is the CCI route switch, CCI service provider, security, and voice and collaboration. Now, even though this webinar is about configuring DOT1X, but I will still skim through just the basics of what exactly is DOT1X and what is MAB. So what exactly is DOT1X? It's basically, it defines how to provide authentication to end devices who connect to switches or access points. So normally, let's say if I connect a PC or a device to a switch, whatever that device or that switch is in whatever VLAN, it gets access to that network. But now with DOT1X, I could actually do an authentication for that end device by authenticating him through an authentication server, which could be ICE. So basically a port-based authentication, which can be used to prevent unauthorized devices from gaining access to the network. It also allows network access for devices attached to the network port. If authentication succeeds, he gets access to the network and he can connect. If the authentication does not succeed, he gets an access reject from the authentication server and he does not get access. So in short, it can provide authentication and authorization services at network port level. So what are the basic components of DOT1X? So it mainly is comprised of 3 components. We have the supplicant, which is the most important one for DOT1X. And then we have the authenticator, and we have the authentication server. Supplicant is something that resides on the operating system. It could be like an application which is on your device, on your operating system. Something like it could be AnyConnect, which could be a supplicant, or you could use the Windows built-in supplicant. The authenticator is the device where your supplicant or your PC would connect, which could be a switch or it could be an access point. Authentication server is something like ICE or your ACS server, where you could ask the communication which is done between the authenticator and the authentication server is going to be done through Radius. So authentication server, an example of that would be my ICE. Now, how does the communication actually happen between the supplicant and ICE? How does that actually happen? Well, the supplicant talks to the authenticator, and that is done with EAP, which is Extensible Authentication Protocol. The communication between your authenticator and the authentication server, that is through Radius. Now, if you look at this example, I have a supplicant, which is a PC. I have an authenticator, which is my switch, which could be an AP also. And then I have an authentication server, which is going to be ICE or ACS. So we have EP over LAN, which is the communication between your supplicant and your authenticator. We have Radius, which is the communication mechanism between your authenticator and authentication server. So let's quickly look at the authentication process. How does this whole thing work? How does the communication happen between the PC? How does the PC talk with the authenticator? How does the authenticator talk with ICE or any authentication server? So step 1, it's basically divided in, I believe it's 10 or 11 steps. But let's look at step 1. So this one, the step 1 is basically as soon as the PC connects to a switch, he first sends an EP over LAN start message where when the supplicant connects, he basically sends it as the destination address would be a multicast. It's a special destination address, which is 0180C2000003, which is used to identify the authenticator. This message comes from the PC or the supplicant towards the authenticator. Again, looking at this example, I have my supplicant, which is AnyConnect or the Windows supplicant, sending an EAP over LAN start message to the authenticator to identify the authenticator. I have a Wireshark capture here, which will actually show you that the message came from the PC, the supplicant, as the source MAC address, and the destination MAC address would be that special destination MAC address, which is used to identify your authentication or the authenticator. So if you look at this Wireshark capture, I have the source address, which is here, which is my PC, and the destination is my special MAC address, which it sends to. If you look at the EAP, it's an EAP start message, which comes from the PC or the supplicant to find the authenticator. Now, this is my step one. As soon as step one gets over, the authenticator has to send some response back, which is going to be an EAP request identify. So the authenticator is going to send back a message to the PC or the supplicant saying, okay, who are you? What's your username? So that's a response coming from authenticator to the supplicant. So this is used to request identity information from the supplicant, for example, username. Again, looking at this diagram, this is a message coming from authenticator towards the supplicant. So the first one was basically my EAP start coming from supplicant to the authenticator to identify the authenticator that I have joined some network or I have connected to the switch. The authenticator sends back a response saying, okay, who are you? So that's my EAP request identity, which you can see in my Wireshark capture. So my authenticator is sending back an EAP message, which is request, the code is request, and the identity is my type. So who are you? That's my step two. Now, once that happens, step three is going to be a response coming back from my supplicant. So that's a response which is basically a response coming back from the supplicant towards the authenticator, and he is going to identify himself with a username, which could be anything. For example, Bob. So again, this is step number three, coming as an EAP response to that identify message which the authenticator had sent me. And here you would see that message which says, okay, my username is Bob. So my identity value is going to be Bob, and it's going to be a response to the type, which is identity. That is step number three. Now, what does the authenticator do with that? He gets the information from the supplicant that, okay, this is a user, Bob, who's trying to connect. What does he do with that? He needs to send that information to ICE, which is my authentication server. Now, is that going to be an EAP message? No. The EAP is only between the supplicant and my authenticator, and the communication protocol, which is going to be between my authenticator and the authentication server, that is going to be through Radius. So step number four is going to be a Radius access request going from my authenticator, which is my switch, towards the authentication server, which is ICE. So that's an access request. This access request could go to the ICE on UDP 1812 for authentication, and for accounting could be 1813. However, ICE does support even the older RFC versions, which is 1645 and 1646. So depending on what you want, you could go to your switch and change your authentication port to use 1812. Default is the old one, which is 1645 and 1646. So this is a Radius access request being sent to to your authentication server, which is ICE. What does it contain? That, okay, I have a user, Bob, who needs access. So ICE is going to check his database, that does Bob exist? That database could be his local database. It could be maybe an Active Directory. So any identity source could be defined. So that is step number 4. So again, that's an access request going from authenticator to your authentication server. If you look at your Wireshark capture, you see the code as access requests. And again, if you see here, you can see that it's a radius protocol. It's not EAP. EAP was only between supplicant and your authenticator. And now you have radius between your authenticator and your authentication server. So that's a request coming in from my authenticator towards the authentication server asking, I have a user, Bob. He needs access to the network. So that was step number 4. Step 5 is going to be a radius access challenge coming back from the authentication server to your authenticator. The access challenge message from the server does not only contain the challenge, it also contains what authentication method we should use for communication. For example, what's the method that I'm going to use? ICE is going to send that information in your access challenge saying, okay, I'm going to use EAP-TLS as the authentication mechanism. Does the supplicant support that? That depends. If the supplicant supports that, he would say, okay. If he does not support that, then he's going to send back a NAC message saying that I don't support EAP-TLS. So as of right now, in step 5, ICE is sending back to the authenticator saying, okay, here is my access challenge, and can we use EAP-TLS? So again, this is a message coming from authentication server towards your authenticator. What does it contain? It contains that, okay, this is an access challenge. It contains the EAP method that ICE is suggesting that we use. So that's an EAP method that your supplicant must support. So as of right now, your authentication server is asking that let's use EAP-TLS as our authentication method. Now, does your supplicant support that? Well, that depends on step number 6. So the authenticator receives the access challenge message, which is from the authentication server. He converts that, or he prepares an EAP request message and sends that to the supplicant. So radius challenge came from authentication server towards the authenticator. The authenticator now prepares an EAP message because the communication is only EAP between your supplicant and your authenticator. So he prepares an EAP message saying, okay, here is an EAP request auth saying, okay, do you support EAP-TLS? So that's a message coming in from my authenticator towards the supplicant, which is an EAP request auth asking, do you support EAP-TLS? Which you can see here that the method suggested by the authentication server is EAP-TLS. Now that depends on my supplicant. Do I support EAP-TLS? So that's going to be my next step, which is going to be step number 7. Now this step could be omitted if, let's say, the supplicant did support EAP-TLS. But let's assume that the supplicant did not support EAP-TLS. What happens then? So if the supplicant is not configured to support the EAP method suggested by the authentication server, then the supplicant is going to send back. He's going to send back an EAP response auth NAC message to the authenticator that I do not support this. Here is what I suggest. So the supplicant is now going to suggest that I don't support the one that you recommended. Here's the one that I support. That's your step number 7, coming from supplicant towards the authenticator. Again, that's an EAP message. You would see that in your Wireshark capture that he sends a type as NAC that I do not support EAP-TLS. Here is what I support, protected EAP. So this is what I am suggesting to use instead of EAP TLS. So the supplicant is now saying that to the authenticator that let's use this. Why don't you tell ICE that I don't support EAP TLS, this is what I support. Now again, the authenticator has to convert that as a radius message. He cannot send EAP. It's going to be a radius message going back from authenticator to the authentication server. What is that going to be? That is again going to be an access request. If you remember earlier also there was an access request. When in the first part, in the first access request, it was just, okay, this user needs access. But now in this access request, it's going to contain the authentication method which my supplicant suggested. So my authenticator now sends the radius access request to the authentication server, which you would see in your Wireshark capture, that I support my protected EAP as the authentication method. Step number 9 is going to be to send an access challenge back from my authentication server towards my authenticator. Now this is going to be based on the method that the supplicant said that let's use the protected EAP, and that's what's going to be in my access challenge message. So I have a radius access challenge coming in from the authentication server towards the authenticator, which is then going to be converted to EAP message in the next frame, where if the user is correct, if the username exists, if the password is correct, then he gets access, which would be your next step, where an access accept message comes in from my ICE, which is the authentication server. If the username is correct, if the username and password is correct, he gets access to the network. So an access accept message comes back from my authentication server. If the username is incorrect or the user does not exist, then an access reject message would be sent back from the authentication server towards the authenticator, which the authenticator would send either a success to my supplicant, or he would send him a fail or a reject to the supplicant. So if the credentials are wrong, the authentication server will send an access reject message to the authenticator, which is my network switch. If the username is correct or it's valid, he sends an access accept message. So what does the authenticator do with that? He sends him an access accept, which is coming in from authentication server to my authenticator. Once the authenticator gets access accept, he sends a success, an EAP success message to the supplicant, which you would see here in my Wireshark capture, where I have the code 3, which is success, which is an EAP message. This is how it actually communicates. This is all behind the scenes what happens when you actually configure DOT1X. Let's quickly go have a quick preview on MAB, and then we can get directly on the configuration. So what exactly is MAB? So MAC authentication bypass is similar to DOT1X, with one exception. The client does not support or does not use a supplicant. It could be like an old printer or a fax machine, which does not support maybe a supplicant. But nowadays, all new machines or new devices, they have supplicant built in, or they do support DOT1X. But if you look at, let's say an old fax or a printer, they would not support DOT1X, or they would not have a supplicant. In that case, if you do want authentication for that device on that port, you would have to do MAB instead of DOT1X. So if you cannot do 802.1x, then how do you secure that device, or how do you secure your network from any unauthorized device connecting? Well, that could be done with MAB, which is MAC authentication bypass. Now, one thing that you must know about MAB is that when you enable MAB on the switch port, the switch will drop all frames except the first frame. He needs that first frame. The first frame is needed for the switch to learn about the MAC address, because the MAC address is going to be the username that he sends to ICE. Because again, there's no supplicant when we're doing MAB. There's no supplicant on the end device. For example, a printer, an old printer, that printer is not going to send me a username. So as soon as I connect the printer, the first frame which comes in, that is permitted so that the switch can learn about the MAC address. Once it gets to know about the MAC address, all frames are dropped, and that MAC address is sent as a username to your authentication server. Again, that's going to be a radius message. So there are different MAB configuration types, and there are two ways to actually configure MAB. You could configure MAB as a standalone, where you only use MAB for authentication on all your ports. That's one way. Again, that's kind of not recommended. Then we have fallback. We could use MAB as a fallback for 802.1x. So in case if the attempt for 802.1x does not work, it falls back to MAB for authentication. So two ways of actually configuring it. You could just use MAB and do it for everyone, or you could use MAB as a fallback for DOT1X. Now again, by default, this is very important that by default MAB only supports a single source to connect to that port. If more than one source connects to a port, or if more than one MAC address, source MAC address is learned on that port, it causes a security violation. Now this can be an issue, right? Because imagine if you have a switch which connects to a phone, and behind the phone I have a PC. What's going to happen? You would learn two MAC addresses, the phone's MAC address and the PC's MAC address. And that's going to be a problem, because the default behavior in MAB is that it only supports learning one source MAC address. If it learns more than one, it would trigger a security violation. But you can change that. You can change that behavior. That can be done by configuring different host modes. So we have 4 different host modes available. We have single host mode, which is the default. So here only one single source is allowed to connect. So any more than one would trigger a security violation. This is the default one. So where would I use something like this? Maybe a printer or a fax machine. But what if I have a phone which is connecting? I have a phone and a PC. That's where we have the second mode. We have multi-domain authentication host mode. Here, this basically allows 2 MAC addresses to be able to learn on that port. One would be a voice VLAN source MAC address, which is your phone's MAC address. And one is going to be a data VLAN's MAC address, which is going to be your PC's MAC address. So if you have one phone, one PC, then you would use multi-domain as the host mode. You would have to explicitly change that on the port because the default is single host mode. Any more than 2 MAC addresses, which is one voice, one data. It cannot be 2 data. It has to be one voice, one data. So if it's anything more than that, it would trigger a security violation. The next host mode that we have is multi-auth, which is also known as multi-authentication. This basically, again, supports one voice and multiple data. So I can have one voice source MAC address being learned, and I could have multiple data MAC addresses being learned. The difference here from the previous one, in multi-domain, it was one voice, one data. That's it. Here, we have one voice, multiple data. So imagine if I have a phone, which behind the phone, I don't connect maybe a PC. I maybe connect a switch or maybe a hub, and I have multiple PCs behind that. So when you have multi-auth, your voice would get authenticated, your data would get authenticated. However, your data, each source in that data VLAN is going to be authenticated separately. So each source MAC address is separately authenticated. This is multi-auth. And the last one is multi-host, which allows multiple source MAC addresses to be learned. Here, there's no voice traffic. It's only data VLAN. So you can learn multiple data VLAN source MAC addresses. However, only the first source MAC address gets authenticated, and everybody else who's behind him automatically gets permitted. So it's one source who gets authenticated, and whoever's behind, everybody else gets authenticated. Can I use this if I have an IP phone? No, because this only supports data VLAN. So I cannot use this if I have an IP phone. I have only two choices to use if I have an IP phone. The first one is going to be multi-domain or multi-auth. So these are my basic host modes available when I configure MAB. So let's look at now DOT1X and MAB in action. So we will actually configure this. Let me show you my topology. So I have ICE, I have a router, switch, a phone, and a PC. So ICE is going to be my authentication server, whose IP address is 172.16.3.100. That's my authentication server. Router is going to act as a DHCP server and also as a CME router for my phone to register. So all that has been pre-configured. Switch is going to be my authenticator, whose IP address is 155.1.143.250. For the phone, I would configure MAB. Now again, can I do DOT1X for the phone? Yes, you can. You can do DOT1X for the phone also. However, you do need the phone to be physically present in front of you to provide the credentials on the phone. Because if the authenticator is going to ask the switch for authentication or for the credentials, the phone should be able to provide that. And that can only happen if you have the phone physically in front of you. So obviously I don't have the phone right here in front of me. So I'm going to do MAB for my phone. And for the PC, I would do DOT1X because the PC has supplicant installed on that. I have Windows supplicant and I have AnyConnect. I could use any one of them. So this is going to be my setup. Let's quickly go and pull up the diagram and the routers. So I have my diagram here on top. And I have router 1, which is pre-configured for DHCP. Show run section IP DHCP. So I do have DHCP for phones. There's a voice VLAN subnet. The default gateway for my phone is going to be my switch. Switch has an SVI VLAN 28, which has this IP address. And my PC is going to be in the VLAN 82, which would be in the subnet. And the default gateway, again, would be the switch, which has an SVI pre-created on the switch. So again, all my routing part has already been pre-configured. So at this point of time, if I go to my switch and I do a ping to ICE, I should be able to ping or reach my device or my authentication server. I should be able to reach. Even from my voice VLAN, the SVI, and even from my data VLAN. Can the phone or the PC ping ICE? At this point of time, I really don't know, because maybe it can if it's received an IP, or maybe it cannot if it has not been assigned an IP. So we will check that. So the first thing what I'm going to do is I will start with configuring switch 1 with DOT1X and MAB. Basically, I will bootstrap the switch. It's very important that you bootstrap the switch correctly, because if you actually look back at ICE, let me pull that screen here. If you look back at ICE, there are some built-in authorization rules which are available. So if you see for the phone, there's a built-in rule which is Cisco IP Phone, profile the Cisco IP Phone, which says if the condition is that if it profiles, if ICE profiles that device as a Cisco IP phone, it would match that rule and give him the permissions, whatever is inside the profile, which is Cisco IP phone. And that Cisco IP phone profile, authorization profile, would contain access accept, voice VLAN permission, and maybe a DACL, which would have permit IP NENE. So bootstrapping the switch is extremely important. Now, how will ICE know that, okay, this is a Cisco IP phone? I should profile him as a Cisco IP phone. Why is profiling so important? Because imagine if you had 1,000 phones, and if I don't profile them correctly, what's going to happen? ICE would not be able to identify that this is a phone or is it a Cisco device. If it's not able to identify, what's going to happen? He would probably he would incorrectly profile him as a Cisco device, not as Cisco IP phone, which means that I have to manually go to each and every phone, edit their policy group, and put him in Cisco IP phone for this phone to match this policy, which is going to be, it's non-scalable. So profiling becomes really important. So obviously profiling is based on certainty factors. So it's really important that you bootstrap the switch correctly, because the more information you send to ICE, the authentication server, the more information you send him, better for ICE. For example, think about the certainty factor as something like brownie points. Like, okay, if you are a Cisco device, I'm going to give you 10 points. If you are a phone, I would give you 50 points. That makes a total of 60. If you are maybe 8845 series phone, I would give you 100 points. And let's say if the total is equal to 150 or 160 or maybe 165, I know it's a Cisco IP phone. So there are criterias where ICE would be able to identify based on the certainty factor. So all communication, which is between your authenticator and the authentication server, is based on attributes, radius attributes. And those attributes tell ICE that, okay, this is a phone. This is a Cisco device. So the more information I send to ICE, better, because now ICE knows, okay, this is a phone. Now, for example, I'll give you an example of this. Look at CDP. What does CDP contain? CDP contains Cisco IP phone. So if that CDP information is sent to ICE, ICE would know from the CDP that this is a phone. DHCP class identifier, that section of DHCP also contains Cisco IP phone. So if I send that information to ICE, ICE would know that this is a Cisco IP phone. So that's why bootstrapping the switch is very critical. So let's start that. I'm going to go back to my switch and start this bootstrapping. Right now, let me show you what's pre-configured. So my IP phone connects to port number 1x0x18. The only thing configured is access VLAN 82, where my PC goes to access VLAN 82, and my phone gets tagged as VLAN 28. So that's pre-configured right now. So the first thing that I would do would be to activate AAA and to define my radius server. So AAA, new model. I have AAA authentication for DOT1X would be through default group radius. I would have my authorization for network default group radius and accounting for DOT1X default start-stop group radius. So I've enabled AAA, authentication, authorization, and accounting. The next step is going to be to define my radius server. Who is my authentication server? So my authentication server is going to be ICE, whose IP address is 172.16.3.100. So that can be done with radius. In fact, this is an old deprecated command. So you can actually use radius server and then define a template. And then inside that, I could define the radius server. But because this switch is probably an older version of iOS on that, it probably supports the deprecated command. So I'm going to do a radius server command. Host is going to be 172.16.3.100, which is my ICE's IP address. And auth port, again, I don't need to define this. The default port is 1645 and 1646. But if I do want to change that to the new authentication port, I could do that. Let's use the new one, 1812, and accounting would be 1813, and my password, let's use Cisco. So now I have defined the radius server. Let's also define which interface of my switch is going to communicate with ICE. So IP radius source interface is going to be VLAN 143, which is my VLAN that can talk with ICE. So if I do a ping, do ping to 172.16.3.100, I should be able to ping ICE. So I have defined AAA new model, authentication, authorization, I have accounting, I have defined my radius server, and I have defined the source of the radius packets. The next thing that I would do would be to enable dynamic author on my switch. The reason I would need this would be for change of authorization. So in case if ICE is going to, let's say, reprofile or reassign him to a different group, ICE would basically send back a change of authorization message. So you would need to configure that. So that's going to be done with AAA server, radius, dynamic author. Now, who is the client of ICE? The switch, the authenticator, becomes the client of ICE, right? Because the authenticator sends a radius access request to ICE. So the client is switch, and the authentication server is my ICE. However, for COA, which is change of authorization, ICE would become a client of switch, because ICE is going to send a request to the switch to do some changes, or maybe do a reauth. So here the client would be ICE now. So client would be 172.16.3.100, and my password would be Cisco. The next thing that I would define would be radius vendor specific attributes. It's really important that you enable that, because if you don't enable vendor specific attributes, it will still work. Like your MAB would work, your DOT1X would work, but your phone or any device which requires a DACL would not be able to get authenticated, and he would not get access. The reason I require vendor specific attributes, because ICE is going to send back a message which says, okay, what kind of a vendor are you? Basically, it needs Cisco AV pair attribute from the switch, so that ICE knows that this is a Cisco switch, and the switch is not going to send that. So if the switch is not going to send that information to ICE, what's going to happen? ICE would say, okay, you are authenticated. As per authorization, I have given you permission, but the DACL, the access list, could not be downloaded on the switch, which means what? What is the default access list he has? What default permission he has? Nothing. So he would not be able to connect anywhere. So you require vendor specific attributes to be turned on. That's mandatory. Or you should, if you have DACLs. So vendor specific attributes send during authentication, and radius server vendor specific attributes send during accounting. These are two things that you must enable. The next thing that I would do would be to enable a few basic attributes that you should enable. So let me in fact show you that. So radius server attribute. If you see there are some built-in attributes available, but all of these attributes are not turned on. There are few attributes that you must turn on. The first one is going to be attribute number 6. This is a mandatory requirement. You should enable this because that's how ICE would know from the service attribute whether the user is doing a login, or he's doing MAB, or he's doing DOT1X. What is he doing? So the service attributes would contain that information when the switch would send that information to the authentication server. So this is something that you must turn on. And the second one that you must turn on is going to be framed IP. Now this is not mandatory, but I recommend you enabling this. The reason is, you remember I told you about that the more information you send ICE, the better. What is that? For example, DHCP. ICE is not my DHCP server. Router 1 is my DHCP server. But I'm going to capture that DHCP messages, and I'm going to send that message to ICE. So is my switch the DHCP server? No. So how would he know what's the IP address of the end client? He doesn't really know. What framed IP does, it basically sends, if the switch knows the IP of the supplicant or the device, then he would send that information to ICE. The more information I send, better. So I'm going to enable attribute number 6 and say on for login, and then radius server attribute number 8 include in the access request. So if the switch knows the IP of the client, send that IP to ICE. Because again, I could classify, if I was doing custom profiling, I could even classify based on subnets. Saying, okay, if somebody has an IP address from this subnet, then put him in this profile, or maybe profile him as an INE devices. Could be anything. So I'm just sending enough information to ICE. The next thing what I'm going to do is enable IP DHCP snooping. Again, like I said, this is only from profiling perspective. It just saves a lot of time. If you bootstrap your switch correctly, it just saves a lot of time in you manually going to your ICE and changing the groups of each and every device. Rather than that, you just configure your switch one time correctly and send enough information to ICE, and ICE will automatically profile him as per the certainty factor. If you actually go back to ICE and look at the Cisco IP phone profile, and if you edit that, you would see that the certainty factor to match that profile is 165. Let me in fact show you that. I think it should be, so if I go back to profiling and let's search for Cisco IP phone, so this is my Cisco IP phone profile, which was called in my authorization rule. If I look back at that, what's my total certainty factor for ICE to confirm that this is a Cisco IP phone? Let's look at this. These are all my, like my brownie points or my certainty factor for all these criteria, which says, okay, if the DHCP class identifier contains a Cisco IP phone or Cisco systems, if it contains that, give him 20 points. If the CDP contains Cisco IP phone, give him 5 points. If LLDP contains some Cisco IP phone, give him 20 points. If the DHCP class identifier contains Cisco IP phone, again, give him 20 points. If I add all of these points in total, it becomes 165, which means that ICE, when it gets all the information from the switch, it should match up to 165 at minimum or higher. If it is 165 or higher, ICE would know, okay, this is definitely a Cisco IP phone. And he would automatically profile him, put him in that group, and the rule would match and the phone would get access. So let's go back and see how we can match that. So I'm just going to enable DHCP snooping, and I would enable IP device tracking. Again, this is required for the switch to be able to track the IP of the supplicant or the client or the PC or your phone, because the switch himself is not a DHCP server. So he himself does not know that what is the IP address of that end device. Who is the DHCP server? Router 1. Router 1 is sending an IP to the phone or the PC. My switch is just a DHCP relay, which is going to forward the request as a unicast, because the broadcast comes from the phone or the PC. The switch would become a relay, and he would forward that request to the DHCP server, which is router 1, and router 1 comes back with an IP address. But switch 1 is going to track that now, so he will store that information and send that to ICE, because framed IP attribute number 8 has been enabled. So this command is irrelevant if you don't have this. And this command is also irrelevant. This command is irrelevant if you don't have this, because even if I track the IP, if I'm not enabling the attribute number 8, he's not going to send that information to ICE, even though he knows the IP. So I have IP device tracking. Let's also enable SNMP. So I could have ICE probing and getting information from SNMP. So SNMP server, community, let's give a password Cisco, read only. And we could also have CDP turned on, because again, CDP information is sent to ICE through radius attributes. So radius, your access request carries that information. So let's enable CDP and CDP version 2 for my phone. The next thing that I would do would be, if you remember in the profiling, there was one column for DHCP class identifier, give him 20 points. So what does that mean? I need to send DHCP information to ICE. But is ICE my DHCP server? No, he's not. So what I'm going to do is I would go to my SVI, VLAN 28, which is my voice VLAN. This is where my phone connects. Phone has this as a default gateway. But will the phone receive an IP address? No, because the phone is in the VLAN 28. My DHCP server is not in the same broadcast domain. So it's routing through the switch, which means that I would need a helper address to make that, make the switch into a relay and send a unicast to the DHCP server, and the DHCP server assigns an IP address. So who is my DHCP server? It's my router 1. So that's going to be IP helper address 150.11.11.1. Now there's one more thing I would do. I would also configure one more helper address, which is going to be my authentication server's IP address. Why am I doing that? ICE is not going to assign an IP address to my PC or my phone. ICE is not a DHCP server. So he's not assigning an IP address. So why am I giving this helper address? For my profiling information to be sent, because what's going to happen? My PC or my phone sends a broadcast saying, hey, I need an IP address. So there's a DHCP request, which the switch is going to make that into a unicast and send that to router 1 and to ICE. ICE now, because he gets that information, because the request comes from the switch sent to ICE, ICE will store that information. He doesn't assign an IP address. He only stores the information. He gets information. But router 1 gets information and he assigns an IP because he is also a DHCP server. So 172.16.3.100 is, I'm going to assign that to both my SVIs, which is my voice VLAN and my data VLAN. What next would I do to for bootstrapping? Maybe I could have like an access list configured on my switch, because what's going to happen right now? If I want to send DHCP information to ICE, the minute I enable DOT1X or MAB on my port, everything gets disallowed. The only permission that that port has is the EAP messages. Everything else is basically blocked. So by default, when the PC connects, he has no access except for sending EAP messages. But for ICE to get DHCP information, the DHCP information must reach the switch, and the switch must forward that to router 1 and to ICE. That's only going to happen if I permit DHCP. So I can't just go and say authentication open, because that gives full access to that device without authentication. So I don't want that. So what I'm going to do is create an access list. Let's say, let's name this before login, and say, just give him basic permission. So permit UDP any EQ 67, 68, and everything else is denied. So this is the only thing that he has access to at this point of time. So I make this access list, go back to my port 1x0x18, and here I would say IP access group before login in. So now this port has access to just UDP 67 and 68 and nothing else. So even now, if I go and do authentication open, I need authentication open. Otherwise, only EAP messages go. The DHCP request coming from PC or my phone would never reach the switch. It gets dropped. So I am going to turn on authentication open so that the authentication is open. So the only thing permitted before he gets authorized by ICE is this access list. So now we can actually start configuring DOT1X and MAB. So this was just from bootstrapping perspective. So the first thing that I would do would be enable DOT1X feature on the switch, which is done globally. So DOT1X system auth control. Then go back to my port 1x0x18. You must remember one thing, that you must have port fast turned on if you want MAB or DOT1X to work, because if you don't have port fast, what's going to happen is that your DHCP request will time out. So you should have port fast enabled. Otherwise, even if your DOT1X is successful, the PC would never receive an IP. So make sure you turn on port fast. And I'm going to start off with the first command, which is authentication, port control, auto. So here, what auto does is that the port would be in unauthorized state by default. Only after successful authentication, the port goes into authorized state. That's the first thing I do. Now, this command would only be available if your port has switch port mode access. If your port is not an access port, let's say if dynamic DTP was turned on and you had not given switch port mode access, you would not see authentication commands. That those commands would not exist. So the first command would be authentication, port control, auto. And next I will define my host mode. If you remember, there were 4 host modes. We had multi-auth, multi-domain, multi-host, single host. Now we have a phone, we have a PC. What does that mean? Which one can I use? Can I use multi-host? No. Can I use single host? No. Because I have a phone, I have 2 choices. Either I use multi-domain, which is one voice, one data, or I use multi-auth, one voice, multiple data, but each data is authenticated separately. So either one I could use. Let's use multi-auth. The next thing that I would define would be authentication order. So authentication order, what do I want to do first? Do I want to do MAB first? Do I want to do DOT1X first? So what's my fallback mechanism? Again, if you remember, I had 2 choices. Either I configure just MAB as the primary method, or I have just DOT1X, or I have fallback. In fallback, I could do one first. If the first one fails, it goes to the second one, which is the backup mechanism. So I am going to do MAB first and backup as DOT1X. The problem with this is not going to be for my phone, because phone is going to try MAB first. MAB would be successful, no problem. DOT1X does not start. PC is going to do MAB first, which will fail, and then go to DOT1X, and that would probably pass if I've configured it correctly. So you don't want that. You want that the switch, as soon as the port gets connected, the switch is going to send, like an EAP response or an EAP message saying, do you support DOT1X or do you have a supplicant? If it does have a supplicant, he would skip MAB and directly do DOT1X. So that's going to be with authentication priority, reverse, DOT1X first and then MAB. So if he has a supplicant, he'll do DOT1X straight. If he doesn't, then obviously he'll do MAB. And the next thing that I would do is going to be authentication open. I should enable that. Otherwise, my access list has no meaning because everything is going to be dropped. Even though I have an access list which permits UDP 67 and 68, even that's going to be dropped. Because only EAP messages are permitted when you have DOT1X or MAB configured. So I believe everything should be enough. The only thing left now would be to enable DOT1X and to enable MAB. I would do that later on. The first thing that I will do is, in fact, we can do this right now. I'll just show you the logs on ICE. Hopefully we do have some time. So I'll show you some logs on ICE that what's happening on ICE when the request goes from switch to ICE. So the first thing what I'm going to do is go back to ICE, and I believe it should be in settings and under protocols, radius. I would disable this feature right now, which is suppress repeated successful authentication or request. What's going to happen right now is I haven't configured ICE right now, right? So ICE does not know anything about the switch. Switch is not a client of ICE right now. But the minute I enable DOT1X or MAB on my switch, the switch is going to start sending radius access requests to ICE. And ICE is going to ignore that message because switch is not a client of ICE. So he's going to just silently drop that request. All right, so sorry about that. There was a glitch. So coming back to the ICE part that I was talking about was that when the switch is going to send repeated requests to ICE, ICE is just going to temporarily block him for 60 minutes. So I don't want that, so I'm just going to disable that right now. You would not want to do this in production. Let's disable this and save that. And let's go back to my switch, and I will enable MAB and DOT1X. So to enable MAB, the command is just one simple command, MAB. To enable DOT1X is DOT1X PAE switches the authenticator. So I enable DOT1X also on this device. Let's do a debug also. Debug radius authentication. You probably see that radius request is being sent to ICE, and because I changed my port from 1645, which is the default, to 1812, my request is going to be sent on 1812 to the radius server. So right now I see that, let's do a terminal length 10. So I see here that I am sending a request on 1812 to the radius server, but I get a request timeout. The ICE is not responding back to the authenticator, which is a switch. So the reason ICE does not respond is because switch is not a client of ICE. You can see that in the logs. So if I go back to my logs and go to operation, live logs, you would see here that a request did come from my switch, who's the authenticator. And if I look back at the detailed report, you would see that radius access request was received from the authenticator. It creates a new session. but could not locate the AAA client, radius request was dropped. So ICE just silently drops the message or drops the request, does not send any request back or any response back to the switch. And that's why the switch is seeing that request timeout. He tries 5 times, doesn't work, goes to DOT1X, tries that, doesn't work, goes back to MAB. He keeps trying that many times. What's the solution to fix this? The first thing would be to create, go to administration, network resources, and create a network resource. Let's go and create that. So that's going to be under administration, network devices. Let's add switch 1 as a client of ICE. So add switch 1, and the IP address would be the same IP address that we gave on switch 1 to use as a source, which was 155.1.143.250. And the radius password was Cisco. And I have turned on SNMP also on the switch, so I should be able to probe that. Let's enable SNMP also. We could use version 2C. And community string was also Cisco. Let's submit this. So now what's going to happen, switch sends a request to ICE, but ICE has switch 1 as a client, so he must respond back. So if I look back at my logs now, you would see a different thing. You would see a different message. Look at the difference from earlier to now. Earlier, there was nothing in this identity column because switch or ICE was just dropping the request. Now, ICE will accept the request, right? He has to process that request. Now, what's happening behind the scenes? Let's go back to my switch and see. First, what happened? So can you see, this is actually my phone. My phone authorization automatically worked. I didn't have to do anything. Authentication happened, authorization happened, he got profiled, and he got probably an access list also. So access accept, and he received an access list also, which you can see here for my phone. So if I look back at show authentication session interface fast Ethernet 1x0x18, this is my PC right now. And so right now for my PC also MAB is happening, but that's okay. We would do DOT1X later on. But what I'm concerned right now is with my phone, because I actually profiled my phone as per my switch. So if you see here, the username was the MAC address. So in MAB, the username is the MAC address, because only the first frame is allowed on the switch to come in from the phone so that the switch can learn about the MAC address. All remaining frames are dropped. So the username becomes the MAC address, and he sends that to ICE. Can you see I have an IP address here also? This is because of IP device tracking. So switch knows what's the IP of the device, and that information can be sent to ICE. And if I look back, he received a DACL, which is an access list. And I think if my phone is correctly configured, it should have gone registered. In fact, it has. The phone has automatically registered with the CME router, which is router 1. Now, how did this work? How did this whole thing happen? Let's go back to ICE and see that. We look back at the logs of my phone, which is this one. Let's see what happened. So I received an access request. Obviously, my phone and switch must be communicating with each other. And then the switch sends radius access request to ICE. And the first thing it does, it says that it matched the rule MAB. Where did this come from? So let me show you the order in which ICE processes the packet. As soon as the request comes to ICE, the first thing ICE does is checks whoever is the authenticator. Is he my client? Is switch 1 my client? Yes. If yes, then it goes to policy authentication and processes the authentication policy top down. So here I have 3 built-in rules. One is MAB, one is DOT1X, one is default. If you notice in the log, we saw that it matched the MAB rule. So how does ICE know that you're doing MAB? Because if you look at my debugs, in the debug, if you remember the service attribute I had turned on, which was attribute number 6, that's how ICE knows, okay, you are doing MAB. So it matches this rule. If it does match this rule, what is the action? Does the MAC address exist on ICE at this point of time? No. ICE doesn't know that phone. It's a new phone that I've plugged in. So if the endpoint does not exist, what is the default action? If user not found, don't drop it. Continue ahead. So even if the MAC address does not exist, it moves ahead from authentication to authorization. So now it goes to authorization. In authorization, it's going to try and match rules top-down. You remember we gave so much information on switch to send to ICE. ICE must have profiled him as Cisco IP Phone. So it tries and matches all of these rules top-down again. It matches the condition of Cisco IP Phone. What's the condition to match Cisco IP Phone? If the certainty factor is 165. Let's see that. If I go back to context visibility endpoints and look back at my phone, which is this one, look at the certainty factor. Let's scroll all the way down. I got a certainty factor of 165. You know why? Because I sent DHCP information using the helper command. I sent SNMP information. I sent CDP information. You see, all of the, I sent IP. I sent so much information to ICE that ICE was able to identify or give him all those points, and the total was 165. So it matches Cisco IP Phone. It got profiled automatically as Cisco IP Phone because I sent so much information. Now imagine if I just go to my switch and remove one command, the helper address, which means ICE would never know about all of this DHCP messages, which means 20 points of DHCP class identifier goes away. So it becomes 145, which would not match your Cisco IP Phone. It would be classified as Cisco device in that case. And is there a rule which matches Cisco device in your authorization? No. So if there's no rule that matches the profiled Cisco device, it's going to match the last one, which is deny access and give him no access. But because I profiled my phone correctly, I didn't have to do anything. As soon as the phone connected, ICE knew that this is a phone, profiled him, and gave him Cisco IP Phone, gave him the authorization profile called Cisco IP Phone. So now what's the process? How is the whole process working? First, access request comes to ICE. ICE checks, is switch 1, the authenticator, my client? Yes. If he's a client, go to authorization and a policy, authentication, match a rule. It matches the MAB rule, which says if user not found, continue. Now it goes to authorization policy. In authorization policy, it matches the second rule, which is Cisco IP Phone, which says if this rule matches, give him the authorization profile called Cisco IP Phone. Where is that? That's under policy results. If I go to authorization profiles, you would see Cisco IP Phone there, which is a built-in profile, which contains access accept, a DACL called permit access, and voice domain permission, which is set to true, which means the phone can go into the voice VLAN and get connected. So this is my whole process, how ICE processes the packets, which you can see in my logs also. It matched the MAB rule, and because it matched the MAB rule and authentication passed, so, and then it goes and matches the profile Cisco IP Phone in the authorization profile. It assigns him the profile called Cisco IP Phone and gives him the DACL and returns an access accept message back to the authenticator as a radius message. And then the authenticator sends an EAP message success to the end device, which is my phone or the PC. Now this was MAB for my phone. My phone is already done. It's already authenticated, and I'm doing MAB. Let's do DOT1X for the PC. Let's see what's happened for my PC. I believe right now, if I look back at my logs, let's go back to live logs and look at my PC's MAC address. You remember in the debugs, or in fact on the switch, we saw that the PC also did MAB. Why did that happen? So again, Access request comes to ICE. ICE checks authentication policy. It matches the MAB rule first. I mean, he's doing MAB right now, even though I had DOT1X as a priority, but he must have done MAB first because I enabled MAB first. So he sends a MAB request. The MAC address does not exist, but the default action is continue. So it goes to authorization policy. There, it must have matched the permit access rule. So there's a built-in rule available, which you should normally turn off. Let me go back and turn that off, which is here. It actually must have matched the rule, which is, I believe, the authentication passed. It matched the basic authenticated access. What is the condition for this rule to match? The only condition is that if authentication passes, then match it. That's the only condition. Did the authentication pass for MAB for the PC? Yes, because if the MAB rule matches, even if the user doesn't exist, continue, which means authentication passed. Even though he didn't provide a username password, authentication still passes. It goes to authorization policy and matches this rule, which says give him permit access. So now you should disable this rule, otherwise everybody would get access to everything by default. I'm gonna go and disable this rule and save it. Now my PC MAB would fail. DOT1X he would try, even that's going to fail because I haven't enabled DOT1X as a supplicant on the PC. Let's go back to my device switch and let's do show authentication session. I'll take the session ID of my PC and do a clear authentication session ID, and clear the session, which means now the reauth is going to happen. So he's going to try MAB or DOT1X. In fact, he's trying DOT1X first now because I gave priority as DOT1X. So he's trying DOT1X. Obviously, that's going to fail. Then he would try MAB. Let's go back and check this. Show authentication session interface 1x0x18. This is my phone. Let's look at the PC. So I got an access reject this time, which is a good sign. Let's do an unall now. There's too much messages. All right, so if I go back to my logs and check this, look at the attributes what Radius is sending. This I enabled framed attribute, I enabled attribute number 6. Look at the information. He is, it should be somewhere here. Look at this information here. So I have Cisco AV pair attribute, which is vendor specific attribute. I have my EAP message, framed IP, service type information. All this information is here in my Radius attribute. So if I go back and do a show authentication session and look at this is my PC, let's see what happened. MAB failed, DOT1X also failed. So they both basically failed because now MAB authentication would pass, but authorization matches the last rule, which is deny access, and gives him no access. DOT1X, he's not providing credentials right now. The supplicant hasn't been turned on. So I would turn that on. Let's go back to my ICE and let's create an identity group. I don't have to create a group because there are built-in groups available, like employees is there. Maybe I won't create one. I'll just create a new identity, like a user Bob. Obviously, for me to create a user Bob with the password Cisco, it would not allow me as per the default settings for password policy So I'm going to change that temporarily right now. Minimum length, keep it as 4. Let's uncheck this. Uncheck lower, uppercase, and numeric characters, and let's save this. And go back to identities. Let's create a username Bob. Password Cisco, and let's put him in the group employee. So now I have a username Bob, which belongs to the group employee. Let's go back to my authorization. Do I need to create a DOT1X rule in authentication? No, that's built in. There's a built-in DOT1X authentication rule, which I can reuse. I just need to create an authorization policy, which would be here. Again, if you remember, we have done authentication open on the switch, but we have an access list before login applied, which means he only has access to UDP 67 and 68. So I'm going to create a new DACL for that PC. So let's go back to results, authorization. Let's make a new DACL. Maybe I'll say this is a DACL for PC, and maybe I'll give him access to permit TCP any. Maybe I'll say permit ICMP any, just something like that. I could even have my other things like, let's also add permit UDP any EQ67, permit UDP any EQ68, and maybe permit UDP any EQ53. So this is my DACL created. Let's say if I've misspelled it, yes, any. So I made a new DACL for my PC. And let's go back to authorization profile now. I'll make a new profile for my PC. Let's say auth profile PC. Give him access accept. Give him the DACL, which is PC. If I do want to put him in a new VLAN, maybe change his VLAN. Right now, by default, he is going to go into VLAN 82, which is as per my switch configuration. But if I want, I can ask ICE to tell switch that changes VLAN from 82 to 182. I could do that from here if I do want to add that. I would not add that right now. And let's submit. So the only thing I'm doing is giving him access accept and giving him a DACL. Let's go back to authorization and create a new rule saying DOT1X for PC. What's the condition going to be? If he belongs to employee group, he should do DOT1X. So if he belongs to the user group employee and he is doing a via DOT1X, let's choose that from the condition. I could do a wireless DOT1X also. Let's do a wire DOT1X because my PC is connected through a wire to my switch. Give him the profile that I created, which was auth profile PC, which contains access accept and contains a DACL. Done, save. ICE is now configured. The only thing left now is to enable the supplicant on my PC, which could be any connect, or it could be a Windows supplicant. Because of time constraint, I would not show you any connect right now. I would probably show you the Windows supplicant. So let's go and take the PC as a remote desktop of our PC. That is going to be PCA. All right, so I have my PC now. Let's log in. And I would use the Windows supplicant. That's going to be done by going to my NIC card and right-clicking on that, properties. So right now I don't see the Windows supplicant turned on. So that has to be turned on. It is by default disabled. So let's go to services and search for wired auto config, turn that to automatic and start that service. The minute I start that service, you would see that if I go back to my NIC card, I see the authentication tab now, which has DOT1X. Let's go to settings, uncheck certificate, validate the certificates of the ICE, which I'm going to uncheck right now. Go to configure, uncheck your single sign-on, and okay. I'm using PEEP, protected EAP. And let's go to additional settings, enable user authentication, and let's put the credentials as Bob and password Cisco. So the minute I do this, it should authenticate. Let's go back to my switch and check here. Show authentication session. We could always do a clear. So clear authentication session ID, and clear this so it retries the authentication process. So if it does match that, it should get authenticated for that user. Let's go back to the PC attempting to authenticate. In fact, I think he got authenticated. Let's check back. Show authentication session interface fast Ethernet 1x0x18. That's my PC. Right now it's showing up as anonymous. So it's not using the username Bob. Let's do a shot, no shot to my port. This sometimes happens with a virtual NIC, like a VMware setup. I believe right now he is still using the anonymous as the username. Let's go back to my PC. So phone wasn't a problem. Let's look back at the PC. Yeah, I think it's because of the domain. I think it's because we have inelab.local as the domain. Let's try giving that. We can always look back at our ICE for some more information, for maybe logs. As you can see here that the user is actually sending anonymous. This is probably because of a virtual environment right now. At my PC, I am taking a remote desktop, and the virtual NIC, sometimes it does that. It just requires a reboot to fix that. But that's all that you should need to do. And again, if you do want to see your logs, you can always look at that in your radius logs. That gives you a lot of information. In fact, it also shows you the messages being exchanged between the supplicant and the authenticator and the authenticator and the authentication server, which you can see here. So I have the EAP responses, the EAP challenges. So if you see the authentication is actually failing because ICE is rejecting the local certificate. I believe I did turn that off. I'm just going to re-verify that, which is under settings. I did turn that off. I could use AnyConnect, or maybe it's actually using AnyConnect. That's why it's failing, because AnyConnect is turned on. So it's not going to use the Windows supplicant. If AnyConnect is turned on, it's not going to use the Windows supplicant. And that's probably the reason why it's using anonymous, is because the AnyConnect does not have the certificate installed for ICE. So I'm going to uncheck that because I'm not using AnyConnect as a supplicant. I'm using Windows as a supplicant. And let's do OK. And let's retry this. We can always disable this and re-enable this. Just to retry the authentication process. And go back to our switch. And let's do a clear. So show authentication session. And then we go back to my PC. And I will change. Right now the authentication has failed, so that's a good sign. I will go back and change my username to be just Bob now. Bob, password Cisco. Attempting to authenticate, and here it succeeded now. So the issue was basically that the NIC card had AnyConnect NAM turned on. So it was basically doing AnyConnect as a supplicant, which does not have the certificate for ICE, which you can see in the logs, that I actually got that information from the logs, that okay, that certificate is not imported on that device. So basically my EAP-FAST was failing. So, and this was because of AnyConnect being used. So what I did was I disabled AnyConnect and I use only Windows supplicant. And I redefined my username as Bob, password as Cisco, and I just restarted my process. And now that the user is authenticated, which you can see here, Bob got authentication pass. He got a DACL as well, which means now Bob should receive an IP address from the DHCP server, and he should have some permissions to maybe do a ping or TCP or UDP. You could probably do all those things. Let's go back to the switch and check that. Show authentication session. Let's take the session ID and do show authentication session ID. And if I look back here, username is Bob, authorization success. He got a DACL, and DOT1X was success. If I look at show access list now, this is what the PC got access to. He has TCP any, ICMP any, and UDP 53 and 67 and 68. So he has this access now. So if I go back to my PC, my PC should have received an IP from the DHCP server, which he has, 82 subnet, and he should be able to ping the default gateway, which is my switch. So if I do a ping to 155.182.250, I should be able to ping, which I can. So with this, we've successfully configured DOT1X for our PC, and we've configured MAB for our phone. I hope you guys enjoyed this webinar. Now I would answer some questions. If you guys have any questions, let me quickly have a look at those questions. All right, so I see some questions here. What are the drawbacks of configuring auth priority or the auth order for DOT1X or MAB? See, the thing is that if you define the authentication order, let's say if I do MAB first and I do DOT1X later, it's always going to try MAB first, irrespective whether you have a supplicant or you don't have. Now, for example, let's say for the phone, I want MAB to work. Maybe for the printer, I want MAB to work, right? So I configure MAB as the order, in the order I configure MAB first. But because of that, what's going to happen? My PC who's doing DOT1X would have to do MAB first, fail, and then do DOT1X. Now that's going to take time, right? Because it has to fail MAB first and then do DOT1X. So with the priority, the switch is going to send that EAP message saying, do you have a supplicant that supports DOT1X? If yes, he skips MAB and directly jumps to DOT1X for that PC. So now I can have like a mix and match of both, where my phone does MAB first and my PC does DOT1X first with the priority. Again, I see a question which says, the new switches have the policy map type control. Is this added automatically? Do you have to create this automatically? And are there any important things to know about that? The new switches do have this automatically, but you do have to turn it on. It's like, for example, you still have to have the mode as access, and you have to turn on whichever mode of whether you want auto or you want force authorized or you want force unauthorized. You still have to turn that on. So you still have to select which mode you want. Then I see, where does wired local WebAuth configuration fits in? So nobody does local WebAuth anymore, but if you still wanted to configure local WebAuth, you can have in your order, you could have probably MAB, DOT1X, and then WebAuth for local WebAuth. If you're doing central WebAuth, you don't need to turn on WebAuth. That uses MAB itself. If you're doing local WebAuth, you would have MAB first, DOT1X, and then backup. Last backup would be the WebAuth. Can you explain DACL? So DACL is basically like access list. So instead of me manually creating an access list on the switch, now it's user-based access list. It's not port-based anymore. So like the one that I created on the switch was a port-based access list for everyone, what they get access before they log in. But with DACL, which is coming from ICE, it's a user-based access list. So as soon as a specific user logs in, it doesn't matter which port he connects to, because an access list attached to a port is pretty static. But now if a user is roaming around, he goes and connects somewhere else. If he gets authenticated by ICE, no matter where he sits, he would get the same access list which comes from his profile, whichever is attached to him. So that basically makes it more dynamic and more scalable. It's user per user basis access list. I see another question that, have you seen where endpoint is profiled and still failing map policy using its logical profile? So what are the things to look for? Well, the first thing what I would do if something like this happens, I would look at my logs for specific for that device and see that what endpoint profile is he getting and what's the certainty factor, because sometimes you may match the parent policy, you may not match the child policy. So are there any child policies also? You would want to look at those things. Looking at your logs, the detailed logs gives you so much information that it just spells it out to you that this is the problem and this is how you rectify it. So I highly recommend that you look at the logs, look at the detailed report, and see that what the issue is. It just tells you out. I see a question, what's a good use case? I don't know in what reference is that? So again, I see, what would you prefer, EPTLS or PEEP? It actually depends. So a lot of people would normally use EPTLS, but again, that depends whether you have Windows machine or what end device you have. So Windows can support both, but by default, it would always prefer protected EAP. So again, there's a question which says, what is the default DOT1X timeout and what's the default map timeout? Well, we haven't set any values right now, so it's not applicable right now, but you can set that to have a periodic authentication or a reauth happening periodically. Otherwise, by default, it's just going to be based on whether there is a port bounce or a session authentication happening, or there's a change of profile happening, depending on that. So you could probably configure COA, like a change of authorization. So the minute you create, let's say, a new profile, it automatically does a reauth for that user and changes his profile dynamically. So that really depends. But if you do want to configure that, you can always go to your port and do a session authentication periodic, which basically will ask him to do authentication periodically. And you can define your session timeouts. What recommendation do you have instead of ICE free option to use as I mean, there are many open radius, there are many options as a free, but they probably won't do all the features that ICE can do. Like for example, profiling. Most of the free ones, they would just do authentication and authorization. But ICE does a lot more. It's not about just authentication and authorization. Then the next question was MAB, DOT1X failed, MAB. Appears the failed cert. Yes, the cert had failed for us because I was using AnyConnect, and AnyConnect did not have the AnyConnect profile editor. I had not disabled the certificate check for ICE. So I would have to import the certificate of ICE. Otherwise, it would fail. Then I see a next question for Mac users. If they join Windows domain and install Windows root CSR, can we do PEEP authentication like Windows OS? Yes, you would be able to do that as long as you import the certs or you get a cert for that device. Then I see a question. Could you please explain again why ICE does DOT1X instead of MAB for the PC? That's because the switch is asking that, do you have a supplicant? If yes, then it basically skips MAB and does a DOT1X first because the priority was DOT1X. I see a question, does the authentication server directly talk to supplicant? If not, why ICE negotiates for ETLS? So ICE by default, if you look at if you go back to settings on ICE, the ETLS is turned on. So let me in fact show you that. If you look back at ICE under, I believe it should be under profiles, results, and I go to allowed protocols, default network access, this is what is turned on by default. You see the ETLS is by default, it's turned on. So that's why ICE chooses that. But you can turn on whatever you want from here as default options. You could turn TLS off if you want. Then I see a next question, which is, can you show use DACL under profile? If I understand the question, it probably means that how do you apply DACL to your profile? Again, that was under my authorization profiles. I made an authorization profile. So authorization profile contains the DACL and the access accept, and then authorization profile gets attached to authorization policy. So here is where I called my DACL inside my authorization profile, if that's what your question was. Again, I see a question, how can ICE profile based on DHCP discover messages if the PC first have to go through EAP messaging? See, the only thing permitted by default on the port which has MAB or DOT1X, only EAP messages are permitted. So what's basically happening is that the radius, so the EAP is coming from the supplicant towards the authenticator, but the authenticator communicates with ICE or the authentication server with radius, and radius carries all that information. So if you look at your CDP is also carried forward in your radius messages. You can in fact see that if you want to see, if you go to administration settings, I believe it is in settings, and well, in fact, it should be in the deployment. If you go to deployment and go to ICE and go to profiling configuration, you would see that ICE can profile based on IP helper. This is enabled by default. So if the helper address points to ICE, ICE can get information. He can extract information from that DHCP discover message. Again, radius sends CDP information, HTTP information, LLDP information. DHCP is also carried forward in your radius message. So when the authenticator gets the message from the PC, he sends a radius message, right? The radius message carries all this information towards the authentication server. In fact, I think we did see that in the logs. If I go back all the way up, I believe we did see that the DHCP was getting carried forward in the radius. I think it was somewhere, yeah, if I can scroll back all the way up. So, yeah, if you see, I have NAS information, EAP messages, This is all my information being sent in radius. The vendor type is Cisco. Maybe if you do like a detailed radius debug, you should probably see that. But if you look at my eyes, it actually shows that DHCP information can also be carried forward by radius. I see a question that how do we push the configs that we did on the switch, which is the DOT1X and MAB, to hundreds of switches at one time. Obviously, that's where scripting comes in. So if you have SDN aware applications, and then we have actually configure as SDN, which is network programmability, then you can actually control it from the controller. One example of Cisco's controller is the APKM, where I could actually push configs to multiple devices at one time. Then the next one is going to be, so we do a dynamic VLAN assignment for the data VLAN using DOT1X authorization. We can also do that for the phone under multi-domain. So the dynamic is going to be for the data VLAN. It's not going to be for the voice VLAN. So, but if you still want to do it for the voice VLAN, you could do it with a small hack that your physical port still has to be in the same VLAN, which is a voice VLAN. So in that case, you could have ICE sending him a policy, but usually it's for the data VLAN. Then I see a question, will the DACL override the static ACL configured on the port? Yes, the DACL takes preference over the static ACL. The static ACL is not in effect anymore for that user. It's the DACL which is in effect for that user. All right, so I believe these are all your questions, and I hope you guys enjoyed the webinar, and hopefully I would see you in the next one.